This lesson is on the quotient rule, but I'm going to run it like a normal class. So the first thing to do is the quick quiz. So have a go at the quick quiz using the fat finger rule here, or of course the function of a function rule or the chain rule, and then have a go at the second one using the product rule first, and then if you have time, expanding first. Go for it. Now I'm assuming you've stopped the video and you've had some time to do it, so let's go through this answer quickly. Firstly, the notation. This says differentiate this thing and there's no y or x or anything written in front of it, so I would say then write d dx. So that says the derivative of this is 5. This is the fat finger, we cover that up first. 4x squared minus 3x to the power of 4 times, well, derivative of the inside, so 8x minus 3. And that's, look, fine to write it that way. Or you could rearrange it so that it has the 8x minus 3 first. You could take out a common factor, but it's actually a common factor of x to the power of 4, but I wouldn't even worry about that. So that'll do. That's a fat finger rule. Now the product rule, this one. So just reminding ourselves what the product rule is first. So y dash equals the first, so I'm going to go u times the derivative of the second, v dash, plus the second, it's v, times the derivative of the first, u dash. So that's in words, you heard me saying it, that's how I like to do it. So it's the first, 5x, times the derivative of the second, 3, plus the second, 3x plus 7, times the derivative of the first, 5. And in this case, I would expand because there will be some like terms. So 15x plus 15x plus 35. So you get 30x plus 35. And I said if you had time to expand first. So over here, if you expand the thing first, you get 15x squared plus 35x. So I'm just expanding this thing with the original question. And you get 30x plus 35, which of course is the same, so it's just confirming that that rule does work. It's not exactly a proof, but at least it shows that it works. Okay, the quotient rule, this is what we're doing today. So to begin with, I've just gone straight to the reference sheet. This is exactly how it's written on the reference sheet. So you can use that in an exam, of course. If it says if y equals u over v, so a quotient is the answer when you divide two things, then dy dx equals this thing. What is this thing saying? Well, it's really similar to the product rule in a way, because it is using the top and the bottom instead of the first and the second. I'll just quickly write y equals uv here. This is the product rule up the top. Y dash equals uv dash plus vu dash. So it's kind of similar to that, except it's actually the other way around to begin with, and it's got a minus, and of course it's a big fraction anyway. So in words though, this works for me big time. The quotient rule is the bottom. It always starts with the bottom. So that's why I've written the bottom like that. The bottom is the first thing you start with. So by the way, there's a v on the bottom. So that's why it says v here. So it's the bottom times the derivative of the top. So it's the bottom, v, times whatever the derivative of the top is. So that's what that says as well. The bottom times the derivative of the top minus, it's always minus, the top, u in this case, times the derivative of the bottom, whatever the derivative, whatever the bottom is, all over the bottom squared. Now, I haven't mentioned this that much, but we're going to use these rules, the fat finger rule, the product rule, and the quotient rule a lot over the next year and a half, and more than that if you go to university to do some sort of maths. So a lot of people write it this way. Y dash equals, so this is another way of writing it, just using these dash notations. So it's the v, it's the bottom, v times the derivative of the top, v times u dash minus the other way around, u times v dash over the bottom squared. So that's another way it's written a lot. Let's use it. So just a couple of examples. I'll just stick that in there so that we can actually see it at the top. So classic example here, you've got a fraction. You can't actually rearrange this very easily to make it into something where you don't have to use the product rule. The quotient rule. So this is a classic case of the quotient rule. So I'm going to put it over here. Well, it's written there, so I'm not going to write it again. So here it is. This is the derivative. Now, so already picking up, I'm using the quotient rule. Because in the end, recognizing this is half the battle. That it's okay, it's a quotient, it's a fraction. I'm differentiating it, so I need to use the quotient rule. All right, so here we go. So it's the bottom, 3x minus 1. So that's the bottom, times the derivative of the top, 2, minus the top, 2x plus 5, times the derivative of the bottom, 3, all over the bottom squared, 3x minus 1 squared. So what do we do to make it tidy? Not that much. Don't expand the bottom. I'll make a little note here because that's something that people always try and do. Don't expand the bottom. There's no way that's going to help you. But I would expand the top. Now the reason I would expand the top is that you're going to expand and then you'll have like terms. So let's expand the top. So that's 6x minus 2 minus 6x when you go 3 times 2x. And then you got 3 times 5 is 15, so it's minus 15. Now this is what I mean. This one actually simplifies heaps because you've got 6x, take away 6x, there's no x. And minus 2 minus 15 minus 17. So that's the simplest answer. You might have a minus out the front. It doesn't matter. Sorry. All right. The second one doesn't really. There's not a lot of variance here. This is the second one. So we'll do the same thing. So f. This time this was written as fx equals. So I'll write f dash x for the derivative, and it's the bottom times the derivative of the top. Derivative of the top is 12x squared minus 3. I'm running out of space, so I have to go down here. Minus the top, which is huge, 5x cubed minus 3x plus 1, times the derivative of the bottom, all over the bottom squared. And again, yeah, you're going to, again, don't expand the bottom. I was looking at the top. You're definitely going to get some like terms. So let's expand these two things on the top separately. So this is going to be 12x to the power of 5 minus 3x cubed. So I went that times both of those. Now I'll get that times both of those. So plus 12x squared minus 3. And now expand the other one, minus. I'll put big brackets around it because there's going to be 3 terms in here. I'm going to get 12x to the power of 5 minus 9x cubed plus 3x squared. And then I'm going to put the minus through all of these, or if you're happy doing one go, which I'll do here just to speed it up, I'm going to go 12x to the power 5 minus 12x to the power 5, so that's nice, gone. Minus 3x cubed minus 9x cubed, so that's plus 9x cubed, so that's 6x cubed, 12x squared minus 3x squared, so 9x squared minus 3 just stays there. No, you can factorize that if you want, doesn't really matter. The 3 comes out of it. It's a common factor. So work on these questions from the textbook, which I'll just put in the computer, just so in case you don't want to get your textbook out, to help you with those. So we're talking about bit of click on it first so it actually moves. So exercise 8.09. So I said do the first column, so go straight down here, those two. Right, don't forget the first one, derivative of the top will be 0, so that'll make that one a bit nicer. And then these 3 down here, and then do 2, because I think you have heaps of time, just this lesson, 2 through to 7. Good luck.